Hi everyone, let's talk about the first topic, which is operational amplifier. Okay, operational amplifier, or the short form is op-amp. It is a solid state device with a certain voltage gain or amplification. Okay, it can accept DC or AC input, and the output will be a linear or non-linear. And the operational amplifier gets the name from the max operation, which is the addition, subtraction, integration, and differentiation. This is when op-amp is used in analog computer, as an analog computer. Okay, that's the short name, op-amp. And we have a linear and non-linear application, for example, as a voltage comparator, regulators, active filters, oscillators, timers, and many others. Operational amplifier is available as an IC, integrated circuit. It is analog integrated circuit, consists of transistor passive element fabricated in a single chip. It is available, for example, for this, as in dual inline by Brown, okay, or it can be available in terms of a surface mount, and this is another package of op-amp. Okay, it can also available in terms of metal can, and this is another form of op-amp. But usually you'll see this one, the 8-pin dual inline. Okay, this is the part number 627. Usually you'll have a 741 because it is a general purpose op-amp. Okay, so what is inside that black box? It is actually several parts or several stages of amplifier. The first stage will be a diff amp, differential amplifier, and followed by several other stages to amplify the gain, and the last part usually is a common collector amplifier. So you have to input at the positive terminal, negative terminal, and just one output. It will propagate several stages of amplifier before you get an output. Okay, so this is one example of the internal circuitry of op-amp. So here again, the terminal positive, terminal negative, this is differential amplifier on the first stage, another differential amplifier at the second stage, so that you will have a very high gain, and followed by a push-pull, and this is a common collector. The output is taken at the emitter of the last section. This is another example of internal circuitry of op-amp. This is from different manufacturer. You have two input just now, positive input, negative input, one output. Of course, you have a power supply plus VCC minus VCC. This is offset input. I will talk about the offset input later. This is another example. Still, you have the input, inverting, which is positive terminal, inverting input, negative terminal. This is differential amplifier. Okay, you have plus V, which is your supply, positive, negative V minus VCC, only one output. So this is several stages of amplifier, and the output is taken here. Okay, apart from two inputs, one output, two power supply, you have offset now, pin 1 and 5. So basically, we can summarize, we have two input, which is non-inverting, the positive terminal, the negative or inverting input right here, positive supply, negative supply, and one output. So this is a dual inline, 8 pin, which is 4 on one side, another 4 on another side. So this is your input, pin 3 positive, pin 2 negative. The output is at pin 6. This is your plus VCC minus VCC. Pin 1 and 5 is nulling input, and one pin is not connected to anything. Okay, and this is the ideal characteristic of op-amp. First is it has a finite voltage gain, meaning that the gain, AOL or open loop gain, is infinity. Okay, and the second characteristic is it has a finite input impedance. Zi is also infinity, it's very large value. But the output impedance, it is opposite. Your Z out is 0. It also has a finite bandwidth. At all frequencies, the gain will be constant at a certain value. And there is no delay between the input and output, meaning that if you put something at the input, immediately you will get an output. There is no delay, or we call it no slew rate. And op-amp should has a very high CMRR, which is a common mode rejection ratio, meaning that it can reject or reduce noise. But basically, you won't be able to get all those ideal characteristics. The typical value for your open loop gain is usually more than 100,000. Sometimes it could be 200,000. Okay. And as for the input impedance, it is basically about 10 mega ohm. For output impedance, it is less than 100 ohm. And the bandwidth is limited to a certain frequency, meaning that the gain will drop at a very high frequency. Since I've shown you that op-amp is made from several stages of amplifier, so there will be a delay between the input and the output, so meaning that there is a slew rate. Okay, and finally, the common mode rejection ratio, the value is about 90 to 100 dB. So if you want to compare one op-amp to another, the op-amp with highest dB will be better than the other one.